All right, 12.4 is probability. Probability are true outcomes over total possible outcomes. Probability is always between 0 and 1. You will see probability written as a fraction, because those are the only things between 0 and 1, or a decimal, because fractions are decimals, and percents, because you can change decimals to percents. So probability can be written as fractions, decimals, or percents. And you need to be able to change and go back from one format to the other and know how to write them as well in all formats. We have three different types of probability. The first probability is theoretical. Theoretical is what you think will happen. I think the ball will land in the square 5 times. Then there's experimental. It means when you throw it and you actually threw the ball into the square and it only happened 4 times. Then there's geometric probability. And geometric probability is of shapes. Like you're trying to throw an arrow at a dart at the dartboard and you're trying to get into the bullseye. What would be the probability of getting into the bullseye? Well, that's of shapes and areas. So those are the 3 types of probability that we use. When it comes to probability, some things are mutually exclusive. And a mutually inclusive event, I think I said exclusive, but inclusive event is when 2 things overlap and they count as 1. For example, if you're going to, what's the probability of drawing a king or a red card? Those are mutually inclusive because kings can be diamonds and hearts, therefore they can be red. So those are inclusive events, 2 events that overlap and count as 1. Mutually exclusive means they are 2 separate events and they do not overlap. For example, what's the probability of drawing a king or a jack? Those 2 things are one or the other. They cannot be both. The odds. Odds is a little different than probability. Probability is true over total possible. Odds is true over false possibilities. All right. Probability of rolling a 6 on a die. Well, there's only 1 6 out of 6 possible. But the odds of a 6, well, 1, but then there's 5 of them that are false, so it'd be 1/5. So odds and probability are different. The probability of an event. What you do is you take the probability of the first one, you add it to the probability of the second event, and you subtract their overlap. So if we were looking at the example of a king or red card, probability of a king, well, there's 4 of them out of 52 in the deck. Probability of a red, well, half of the deck is red, so it would be 26 out of 52. And then you subtract their overlap. Their overlap is 2 out of the 52. All right, so the king, the red, and then you subtract the red kings, which would be 2 out of the 52. Now, if you're looking at a king or jack, you do king, you do jack, but they don't overlap, so that's not part of the equation. It's 0, so it doesn't affect anything. But that's your probability of events happening. This little upside down horseshoe kind of thing there, that's their intersection. That means what they overlap. And so when you see that little horseshoe, upside down horseshoe, that one means and. It means it's in this and it's in that. The probability of king and the probability of red. So that upside down U means and intersection. The complement of an event is this little kind of tilde mark. So the probability of not an A. So the little tilde means not. The complement is the other part of it. So if I want the probability of A, the complement is probability of not A. It's the other part. And you read it, and I always read it as the word not. Instead of complement of A, I always say, what's the probability of not getting a red card? What's the probability of not getting the jack? Probability of not getting the king? And that generally works a little bit better for us. And that will sum up 12.4 on probability.